Okay, welcome to another conversation. I'm really excited to have Jim Dowling with us. Jim is the founder and CEO of Hopsworks. Welcome to this conversation, Jim.
Thanks, Joyce. Great to meet you again.
Absolutely. So tell us more about Hopsworks, your background.
Yeah, Hopsworks it's a platform for developing and operating AI applications at scale. It's primarily known as one of the first what we call feature stores, a data platform for AI systems. So for storing data for training and for particularly building real-time AI systems. So if you think about the technology that powers TikTok, TikTok has this kind of very interactive feel when you click and you swipe, it adapts to your behavior. That's the kind of platform we build to support those type of applications. A little bit of my background. I came into the startup world a bit later in life. I worked at the university for many years. I also worked at MySQL, and the company is kind of a blend of MySQL. We forked a database from MySQL. That's the core technology, and then we built out a platform on top of that database. That database is now called RonDB, open source, and Hopsworks is kind of this scalable data AI platform. And I guess for your viewers, it's probably think of it as being Databricks but real time. So we actually got the analytics part as well, more
That's
real
really
time.
cool. Yeah.
Yeah.
And did Hopsworks grew out of your research?
Well, it originally, I mean, everything starts. I'm a systems researcher originally, so I work both in AI and in distributed systems, and we started building this scalable data platform on top of this database for DB, and this is maybe at this stage it's 10 years ago we started, and we said, okay, well, what will we do with a scalable data platform that has both like low latency data and then scalable data storage? And we won some prizes for our file system, HopsFS. And we thought, okay, AI is kind of a really exciting area. So we built in specific support for how to manage multiple tenants on a single shared cluster. And then we started adding compute and support for GPUs, and it just kind of snowballed from there. So then it became a kind of a scalable data platform for AI is how we actually raised venture capital funding. We're a venture capital funded startup. And then from there, we then got our first customers, and that's kind of how it grew slowly. But enterprise software is a very because we're an enterprise software product, we're not selling directly to consumers so much, or we haven't been so far. We'll get into that maybe a little bit later with a SaaS platform, but been selling primarily to large organizations, so very large companies, Fortune 500 companies, but also across a many wide range of of verticals. So we have everything from like law enforcement, defense to banking, insurance, healthcare. It's a wide variety and of course entertainment and e-commerce.
Yeah, I'm curious, Jim, if you can talk more about the problem that Hopswork is trying to solve. You hear a lot of people talking about data infrastructure, data platform, now AI infrastructure, but always feel like Hopsworks really understand the piping
Yeah.
to really enable organizations to actually get on and do more complex things like model building, etc. And so, given your background in distributed systems and AI and serving these large customers, what are the core problems that Hopsworks is focused on solving? If even if there is a spectrum, because I know every customer is different.
Yeah, I think the hardest problem most customers have is that they sit on a lot of data and they realize that we can generate value with AI using our data. But then the problem is, how do we get our data to the models? Either if we're training them, but many people are not training them now. They're using off-the-shelf, frontier LLMs. But you still, if even if you have a frontier LLM, you wanted to use your private data to build a service or whether it's internal or external facing service that generates value. So your data will now be called context. That's the kind of
Right.
term we use for data that helps LLMs make better decisions and execute tasks better. But how do you get that data to the models? That's the hard challenge, really, ultimately. And a lot of that data will be in databases. It's not just in files. And it's not always going to be in what we call vector indexes or vector databases, which was kind of the early work that we did in LLMs for RAG. For us, primarily, we say, okay, if our data is in databases, how do we centralize it so that you can make it available for AI? And then how do you, in a governed, secure way, make that data available to be used for making predictions with AI, what we call inference, but also for training AI models? And that's kind of the value that we add. And I think, I've taught on a course, briefly lectured on your course, Joyce, and I've been teaching a course at KTH. And what we do there that's a little bit different, and also the book I just finished for O'Reilly is how do I structure an AI system? And I think that
Yeah.
architectural question is something that a lot of people get stuck on because they might build their first AI system, might be a dashboard that maybe predicts something that runs at a certain cadence every day it's updated. In the book, I cover air quality predictions as a dashboard. It's a nice system. But then you move on, you say, well, I'd like to build an interactive system. Maybe it's going to be something like in the book, I cover credit card fraud. It's a real time. I want to make a decision in 20 milliseconds about whether this credit card transaction is potentially fraudulent or not. And then you move beyond that and say, well, I'd like to build an agentic system. And typically people start over from scratch and they go, well, there's no commonality between these systems, whereas in fact there is. And I think that's what the main message in the book is that all of these AI systems, batch, real-time, and agentic, can follow the same general structure. We have pipelines that manage their data. We'll call them feature, context, or vector embedding pipelines. They take the raw data and transform it into the format that you need for your model for training or inference. You have the training pipelines, which are still used, but maybe not as widely deployed in the agentic era. And then, of course, we have then the inference or agentic pipelines, the pipelines that actually make the predictions. They take the data, use the trained model, and they make the predictions for the client. So those three classes of pipelines, these feature pipelines, training pipelines, and inference pipelines, if you structure your systems in this way, it's very easy to build them, whether they're batch, real time, or agentic. And that's what we do in our course. So students build amazing systems in 1 or 2 weeks because they know how to decompose the problem. They can split up into teams, and one team will do the data, one will do the training, one will do the inference, and it naturally composes together into a full AI system. I think that insight for me helped at least me help students build systems faster, and then we translate those insights into helping customers build AI systems and get them in production faster because we know it's still a big challenge.
Yeah.
Even agentic AI is still not reaching production as much as we would like.
Yeah, I love how you said about decoupling or deconstruct the problem, the business problem, but ultimately, when you get to the bill, it's like, what is the structure and what are the components that support to solve this problem, the decoupling and of the technical elements or the system design. I agree with you. That's both conceptual but also technical, and it requires understanding of the business problem, the business logics, the user needs, the client needs, but then also be able to design system maybe that's also flexible and agile because you can't just keep building new systems when a new agent system
Yeah,
pops up, right? Or a new database pops up, or a new model pops up. You want to be able to swap in and swap out these, uh, I suppose, modalities or tools. But the underlying pipelines or pipes should be robust.
100%. I mean, if you let's take the example of a customer support agent, right? So people will be building those as agentic systems now. It needs to be connected to your data. So you want to have a pipeline that makes that data available to the when a user issues a request and says, I need help with some task, you'll need to be able to pull out the data related to that user. So your pipelines need to make sure that that data is available, that it can be queried in a secure and governed manner. And like you said, new model comes out, it shouldn't affect the infra you've built. You should just layer on top of it. And I think that's why we see a lot of work in, context engineering now as opposed to fine tuning of models, because you do some work fine tuning a model, a new foundation model comes out next week, you have to retrain it. It's a lot of work, but the context engineering work that you do lives across new versions of models, and then you can kind of build on top of that as better models become available.
Yeah, just on that, you were talking about you were talking about vector database and RAG, and I know we had that
Mm.
conversation. It seems like ages ago, even though it's not that long ago when people just start talking about RAG, but just because of the pace of how
Yeah.
things are changing, it feels like 10 years ago that RAG was a thing. But the context part, so if you look at organizations and thinking about, as you said, these frontier models, they're quite powerful. And it's not like the old days where every model has to be trained with training data or,
Mm.
tuned or fine-tuned. Um, where is the sort of the the intellectual property for companies that are building products and services relying on frontier models? I've been thinking about that, and I think in part
I
maybe if I play back to you and you can tell me if I'm right or wrong, it's like yes, these companies are using the frontier models and it's the same for everybody. So one way to inject unique innovation and proprietary things and intellectual property and trade secret is the context, is from the data. And they need tooling like Hopsworks and others to do that. But is it also, as you describe, kind of that system design, like what goes into those elements that's also proprietary?
Yeah, there's a lot to unpack here. I mean, I think at the high level, I do think the models are, they are converging ultimately. Um, I mean, ultimately in the long term, there won't be competitive differentiation, I think, in the medium term for LLMs as they exist today.
All of
But
them is
and
just
the
going to
va
get cheaper.
Yeah, well, yeah. I mean, you can see, like, I've been playing with agentic coding, so everyone's talking about cloud code, but I've also looked at Quen CLI and I've looked at Devstral from Mistral, and it's maybe 6 months behind. It's not as far behind as you would expect. So, I mean, I think, in terms of where's the value add for the enterprises, I think you said it's not like the old days. I actually think we've gone back to the old days. I'll
Okay.
tell you what I mean by that, right? So large language models learn by giving them you can ask a large if I give an example of a help desk agent. When an agent issues a query and says the user said this, you're going to pass a lot of examples in the context,
Hmm.
and those examples will tell the LLM this is how I'd like you to answer the question. And the LLM is able to learn from those examples that are passed to it. This is the tone I would like to give. This is the length of the answer. This is the strength, and so on. So we call that in-context learning. But the context window, is very small in size, right? And then if I ask a question and we want to pull in my history, we can't pull in potentially all my history if I'm a very active customer. It's maybe too big. So because the context window again is fixed and finite in size. So we now need techniques, context engineering, to maybe select the correct, let's call it the most relevant context data, and maybe to compress it and maybe to transform that data in a format that the LM likes best. For me, this is feature engineering, right?
Yeah.
This is what we
Yeah.
did. This is what we did pre-deep learning as well, where we did a
Right.
lot of feature engineering so that our decision trees could
Yeah.
better learn the behavior because we had a limited amount of data. We were in a small data regime. I think we're back in that with in-context learning. So what an agent does effectively is it tries to pull in some context data. Think of it as being training data, and it's going to send in a query, and the LLM will use that training data to train a small model to give it a response in the format or carry out the task in the way that you want it to, or send, for example, maybe a response to an MCP tool that's going to carry the task for you. So, in that sense, I kind of think of building an agent as about how do I collect these training data samples and process my source data in such a way that this will work. Now, the thing that I think, just to bring Cloud Code into the picture here a little bit, the inventor of Cloud Code said they tried RAG at the beginning, but it didn't work well. So what they're trying to do is take all their docs and encode it, and then search the docs to find relevant piece of docs to put in the context. But what worked much better was just giving Claude Code general purpose tools. So Bash and the ability to search through your file system. So search through your files with Unix style tools And it's iteratively building up the context window. So they call it recursive decomposition of your
Hmm.
context. So we saw this as the kind of in machine learning, that's what won out. It was general purpose search tooling,
Right.
and the bitter lesson from from reinforcement learning, that general purpose search and learning beats maybe putting the right data into a RAG database. So I think that's something that we've learned, and it's early days to see where we're going, but you can say context windows are not going to become insanely huge, so we're still going to have to work within that regime. And I think context engineering and how our agents find, discover, and iteratively optimize their context, that's really the next kind of challenge. And Cloud Code is leading the way, I think, doing really well in that
Yeah.
space.
Yeah. Cool. Let's you want to show people a bit of sort of what we're talking about and things that you're working on?
Yeah, I can. I would do. We actually have Cloud Code and Hopsworks. But I don't have a demo of it right now. But it's going to come out soon. But so Hopsworks, we have this new SaaS platform. If anybody wants to try it out, which is run.hopsworks.ai, and you can sign up. I think it's free. You get a free tier, and you can try it out. And I'm just logged in there. I have one open here already, but
You want
you
to
just give
share
it
your
a
screen,
Google.
Jim?
Oh, I should share my screen, shouldn't I? That's
Yeah.
probably a good
And
good
then we'll
idea.
pop the link up when we
Yeah.
share the video. Yeah.
All right. So if you go to run.hopsworks.ai, you can create an account there. I'm going to go here. So you can create an account here um, with your Gmail or GitHub account, I believe. I just go to when you go into Hopsworks, you'll get this project, and I think you only get one project out of the box for free. But you can have multiple projects. So you can do development inside Hopsworks. So what we have actually recently is it's in development, but coming out soon is Claude Code in here, where you can create machine learning pipelines, so feature pipelines, training pipelines, inference pipelines. I've been running some examples of pipelines before. Um, what I would recommend to people if you want to try and get started is go to the book. There is a repo for the book here in GitHub. That's this one here. It's called Feature Store Book or MLFS Book. And if you clone this repo, you can do it to your laptop, or you can also do it inside Hopsworks as well. But I'm going to do it to my laptop. I find it a bit easier. So I cloned the book here earlier, and what we can see here is that there's a couple of different kind of starter projects. So we've got batch ones like air quality. I'm going to look at a real-time one called CC fraud. So this is real-time AI. And if you just call setup env, I wrote this with Cloud Code, of course, but it kind of just sets up your environment, makes sure your Python version is correct and your environment variables all set. You can basically run this notion of feature pipelines, training pipelines, inference pipelines from the command line. You can just go inv. There's a data mart which will create some synthetic data for you, and then there's Feldera is a really nice incremental stream processing engine for doing real-time streaming. And then you've got inference and training and test. And if we pop up, I won't bother doing a demo on the inference example here. You can do it yourself. But what you'll get out of this when you run it is you'll get a bunch of tables. So these are what we call feature groups. These store data for AI. So we've got credit card fraud, some features we've computed from the credit card fraud. For example, one to tell you whether there's the distance between two successive credit card transactions is infeasible based on the physical distance between them. But anyway, this is a data platform. You've got real-time data. We call it online. We've got lakehouse data here. We call it offline. A bunch of tables. When you want to train a model, you'll create a feature view, a selection of features for those models that come from all these different tables. And with your feature view, you can go ahead and you see we've got a ton of features there. And we've got this all of these are kind of connected together. You've got your features here from the different tables. This feature view, we create training data from it. We train a model, and Hopsworks like does the whole shebang. So you can,
This is like the feature provenance for
yeah,
those
that's
people who
provenance
are,
and
yeah,
lineage
because
where
people
you
talk
can.
about data provenance, but now you're showing that visual.
Yeah, I mean,
Um,
so the platform kind of maintains the links between your source data, for example, you can have in here, you can have tables that actually reside in BigQuery or Snowflake or somewhere external.
Hmm.
They look like the tables that are actually stored in the platform. But from there, you then create the features, you then train models. You can then, this is a model that I trained for credit card fraud. And then you can deploy your model here. So there's model deployment here as well. So you can, this model is deployed on this is a framework called Kserve, and you can make predictions by sending requests to it. And it'll pull in pre-computed features, compute features on demand, call model.predict, return, and also log all of the predictions as well. So we've got a table here. This logging table will store all of the predictions because we need that then to do things like identifying drift in features
Yeah,
or predictions. So it's pretty much an end-to-end platform for building and operating AI systems, as I mentioned. You can run, there's Git support in here. You can clone your code, run notebooks, run jobs, and things like that as well.
very cool.
But for
Now,
people who
how
want to
does
get started in Python and use Python, it's a pretty nice environment for them.
And Jim, how does this you sort of were making that parallel sort of features and uh context
Yeah.
for so um how do people use this if they were building with large language models or they're experimenting with agents and
Yeah, so we have this thing called deployments here. So deployments here can be you can deploy a large language model on Hopsworks if you have I don't have any GPUs on this cluster you can see. But if you have GPUs in your cluster, you can deploy very large language models. It's using VLM in the background. Another type of deployment, this one here is like a classical machine learning model, but another deployment you can have is an agent. So an agent is just effectively there are things like Llama index programs inside a fast API server, and it's accessible via a network endpoint. And that agent then takes in requests. It uses the large language model then to obviously, if you an agentic loop, it's going to use that to plan and also to,
yeah.
what MCP calls to make, and then it returns back to the client. So, we have another agent tracing work that's coming out very soon. I don't have it to demo here, but just the logging of the agent calls and so on, which is another useful tool that you need to
Yeah.
have in your
Got it.
bow. But yeah, I mean, this is kind of the way direction when people is going. What we do, I think that's a little bit unique here is this all deploys in Kubernetes. So you can kind of do it on your own data center. You're not restricted to only running it in the cloud. You can run it in a kind of what we call a sovereign AI environment as well.
Yeah. So this is especially useful for regulated industries and companies,
Yeah, and we have, like I said, we have customers
sensitive
in
data.
defense and law enforcement and
Yeah.
places like that, and healthcare that aren't necessarily all in the public cloud yet.
Yeah, excellent. Jim, you want to stop sharing and show us
Yes.
do you have your book next to you? What
Do I
is
have
it?
a copy of it? I do. I don't. No, I don't. Maybe I should have. But yeah, it's an O'Reilly book. I don't have a copy here.
But what's the book called?
I'm giving them all away. I had the book here. But people come around, I give them away. The book is building ML systems with batch real time and
Okay.
LLM or agents. So that's kind of
Yeah, very timely.
with
Yeah.
this kind of feature store as the connecting component to sort of build these pipelines together.
Yeah.
Um,
So
I have yeah.
yeah, I mean you have seen so much and obviously you guys are deep with a lot of these clients. Like where do you see things are headed? Do you see a world where you have I mean at least that's sort of my view, but I think some other folks view are more sort of like we're all going to be like in the agents world and all the apps are going to be built by agents. I sort of see like this parallelism. You have certain use cases where traditional machine learning models suffice. You
Yeah.
have agent workflow replacing some of the earlier automation done by RPAs, and you will also have new, large language model power use cases that all sort of coexist. But what
Yeah.
do
I
you
mean,
see? What do you think?
well, I think it's like, the system 1 and 2. Do you remember a few years ago, Andreang talked about, anything in under 5 seconds will be done by machine learning in 10 years. And now we have system 2, which is agents. The most valuable AI system in the world today is still TikTok. It's their recommender system. That's their differentiation. And that's real-time AI. So I think that area hasn't taken off because you need a lot of infra. You need a lot of competence. And what we see now is with the likes of Claude Code, that really opens up the ability for a lot of teams to build these systems that thought it was maybe too hard before. So we're going to see a lot more engineering of AI systems and a lot more models getting into production. I think that's for clear. And they will be a mix, right? It's we're going to have all these different types. But agents, they are special, right? So um, there will be more agents doing more and more things. They'll be helping us doing, you know, I mean, I can see it already in my profession, coding, right? So
Yeah.
coding is being really revolutionized by coding agents. And we can see it already in how we build AI systems and how we do data engineering. In our work and on agents and Hopsworks, we can see that, that's going to change as well. So there's going to be a lot of information workers are going to be have to adapt to new set of
Yeah.
rules and I it will upend work I think for a few
Yeah.
years. It's not clear what'll happen after that.
Yeah. That's a great
But
question.
but
Yeah.
I think it's still for larger enterprises it's still a slower journey because you have all of the issues related to the data I think and the governance and um so there will be an opportunity for faster moving companies, I think, in the next few years to take initiative and leadership in providing services through agentic capabilities. I think that will it will upend some industries, I think, for a while.
So for those that are, who are learning computer science and software engineering, like what should they be sort of thinking about given the new tools out there? Um,
Yeah, I mean, it's a great question. I mean, I taught this course at the end of just finished about a month ago. The book is the actual course material. But I said all the time, please, please, please use coding agents for these parts, right? We have a UI to do for your AI system that you've built. Don't learn it from scratch if that's not your core thing. I think we in our company we build a database, and at that level, that level of work, I think there's still, that's where developers will still reside for a long time because it's not something that systems can build. But I think computer science is still a great place to get into. We're only at the beginning of AI. I would still jump into computer science, but I can see that there will be a period of turmoil where maybe getting a job is a bit harder and people will become disheartened. But I think in the medium term, we'll be producing so much more software and creating so more value that their jobs will appear again. They'll just look a little bit different.
yeah.
Now,
Oh,
what would I learn? Pure computer science? Yeah, I'd still learn it. I mean, I still think my sister is an architect, and I really love architects. They know everything from the materials they build with, the properties of them, up to building the entire houses. And I still think if you're a computer scientist, you should have that same set of skills from, the from the even from the hardware to the operating system to the software stacks on top. You will still be able to build a lot of things and artisan a lot of things now with coding agents, but if you're to build, steady, sturdy buildings, computer science is still I think the main avenue in which you can learn these skills.
great. Well, I think folks should heed to that advice, and I think that's a great insight, Jim. Maybe we'll get you back, Jim, and show us all the new stuff that you guys are launching. But this
Oh
was
yeah,
really cool. We'll give you a shout out to your book, and thanks again for your time. We'll pause our conversation here for today.
thanks, Joyce. Great talking to you.